Cool. All right. Questions from last week.
From us?
Is there a way to make like the compiler actually enforce it, like say a manager for say the texture manager only gets textures put back into the list since they all inherit from the same, like all nodes inherit from the same base class
Well, they're
that list
actually
manager knows about, and the manager base also only knows about the like stuff that list base knows about.
so
That makes sense.
So let me see if I can understand you. Every manager is its own instance, right? So even though it has the same common class, it's going to be repeated multiple times. So therefore, the list kind of knows about itself. So let's just take the texture manager for instance, texture manager, right? And it manages. It's going to use the, the manager here, which will then talk to drawing a blank here.
List base.
Yeah, list base, right? And then from here, this is going into a double link manager, right? And then this actually owns the D-link, right? And then this is the texture.
And then there was the one that D-Link inherits from, which is what list base actually interacts with, that has like the clear on it and everything.
Yeah. There's kind of a pseudo agreement here, and that's just to force a contract, right? So this forces an abstract wash.
Well, and it means that list base doesn't need to know about D-Link.
No, it's agnostic, but these methods here are ultimately required in here, right?
Yeah.
All right, cool. So far, I think I got the diagram right. So the question is, what's your question?
So like for example, in the homework, you have like the add, which has the name and the int x, but for the generic manager, your add doesn't know it needs a name and it doesn't know it needs an int x.
No. Okay, yeah. This is more about the homework specific. I need
sort of, yeah.
Yeah.
It was a question that came up when I was trying to do the generic stuff in the homework.
Yeah, no. So all right. So let me kind of get back to the separation of like kind of responsibilities here. So this PA, which I don't even have the original source code anymore because I blew my computer up. So I'm just happy I hit go on your class and blew it up on the next class. So I would have cried if I didn't have this. All right, so here's this unit test thing. And the whole idea with the unit test is that, all right, so we have it down here like PA, and then we have sprint. All right. And what I'm trying to do here is I'm trying to really kind of give you a playground for the design patterns. And you can well, that looks weird. All right. I am going to actually decline. Somebody's asking for a live transcript. I'm declining this because it actually throws a big box on everybody's YouTube. My YouTube is actually translated. So anyway, all right. So the PA is just a playground to play around with design patterns. I'm going to try to keep it game agnostic. Trying to keep it was just like, you just prove it out just enough to make it through the unit tests. How much you can reuse in the sprint is very optional. It's not designed to be 100% reuse. It's designed that the concepts were set in the PA. So this will be So that's kind of the purpose of this, is just, like here we'll be playing with this one is the pooling, right? We're doing a manager, which needs a lot more work. And then we're doing like the template method, right? To a minor extent. So this is all in first PA. To a minor extent, you don't have to do it, but you can use an iterator. And the iterator will be shook out more in the next PA.
Okay, so we don't necessarily need like the
No.
full setup of what we went over in class.
No. I'm always going to try to take it, and this is intentional. I'm trying to take it a little bit more aggressively in class, and then you can kind of back down a little bit on the PAs. So this way, I go a little bit ahead of you. You can kind of follow this. You take the ball and keep on running with it, or you can, as long as you get like 80% of the concepts during class, you should be able to make it through the PA.
Okay.
So that's the idea. Yeah. There's a lot of things kind of wrong with the manager. And if you saw in the PA, I kind of gave you 100% discretion on how you want to deal with this. So the diagram just has the two interfaces that you have to do. Just manager and node, because I'm hooked on that. And if you go even further in this, to make the unit test work, I need these two functions. Now, if you want to go more crazier, you're absolutely welcome. I think the same thing here. I kind of prototype these things out, and this was the art and the hard part of trying to get this working. Is I don't want to give you guys, I mean, you're going to have my sample code always, and you'll have like working kind of mini sprints working as my lecture notes. But on these unit tests or these PAs, I'm trying to get you to, have a little more freedom, but also kind of stop the fill in the blank. In this case here, I probably would expect that if you want to kind of follow the pattern we did in class, you're gonna have to add a couple more classes in here and nodes and stuff like this. But if you want to kind of go more brute force, you'll see it there too. Why is this thing this hung? Oh,
when are we going to start writing for the game on the actual
today?
Space Invader? Today? Okay.
Yeah. This is just all the prep work, and we're going into it. All right. So I have no idea what's going on here. Yeah. All right. So this is the PA one, and I think some people were having some questions. Oh, now I know what's going on. I need to move it.
Did you not check out?
Right. I don't. This is my clean copy. So always in the reference directory is a pristine, clean copy, which I think is a good thing to have. So no matter how far down the rabbit hole you get, you always have a clean copy. And so here I'll play in this land over here. All right. So you know what? More importantly, I'll just do it in the student directory. Okay, student directory. All right. So one of a couple of people saying, like, I'm a little bit new to Perforce. You'll get Perforce. Just keep asking questions. It's pretty straightforward. It's not that complicated, but I want to kind of show you how to get going with this. So here's student directory. Here's Perforce. So just go in here and this one, student. Okay, so here's Perforce. Check it out. Check it out. Boom. And then so here's everything out in a bucket. And then now go into your code. And there's 100,000 ways to do this, but basically I always check it out. Then I fire off the debugger or the editor. Right. So now here's the case. Let's just hit a quick compile, see where she is. And then run. All right, you're going to get this thing says a dummy exception. This is intentional, right? Believe it or not, this is intentional. Just go into this and hit break and turn off that break. And when you do that, now you can run this again. And then for the rest of the time, it works, right? And what this break here is, and if you're a sick bastard and you really want to like enjoy pain, you can see I put the whole unit test in one file. I didn't like what Visual Studio gave me. I didn't like NUnit. I didn't like any of them. They all suck. So I wrote my own. So here I had to do reflection, and I had to throw a fault. When you had your first error, it has to invoke a fault, and it has to walk up the stack and release stuff. So there's a lot of things going on here. If you're, you know, like I said, if you're kind of disturbed enough to look at it, feel free to take a look at this stuff. But how this works is when it fails a test, somewhere in here, it fails a test, it throws an exception. There it is. So when a test fails, it throws an exception. This exception, this is to basically force me to walk up the stack. And so this exception does nothing. It's not supposed to be handled. So that's why we're suppressing it. And when doing that, now we can get all, you know, we get the test here failed. And we get all the unit tests here. So if you just double click on this, boom, this is what test failed. Boom, there's what will test fail. And the first one that fails, it aborts and gets out of the program. You know, this might have passed. This might have passed, but the first one that goes south on you, there's no point of testing the rest of the unit tests, so it aborts. And that abort mode is what's throwing this exception, right? So you turn off the exception for just that one, just to make it work. And the sad thing is, it's not persistent. So if you leave the program, go back into it, compile, it's going to throw the exception again. So it's as long as this session's active, but you only do it once. And everything works. All right, the second thing is there's a lot of unit tests, and it's a little bit noisy. First of all, I think I need to make this a little bit bigger. I totally apologize. I blew my other monitor, my other laptop up, and so I totally fried it. That's what happens when you spill water on a laptop. So this is a loaner PC, and it's taken me 2 days to get this up and going. All right, so here, output window, there it is. Let's pick that up a couple. There you go. All right, so here's the output window, and these are really long path names. So basically this paths all the way to your file. No matter what file you're in, it'll jump you right to the line of code that's giving you trouble, right? In the unit test, let's go here, back to the unit test, Solution Explorer, unit test. There's the test right here. In this case, there's only one. Let's go double click into it, and you can kind of see here's flags, and then here's tests. So if you use the kind of the Solution Explorer, you get a little bit more easier to navigate than scrolling. But basically what this flag section here is allows you to turn on, turn off your these tests. So you don't have to get 10 errors when you're only working on one test. You can just kind of suppress those. So so here we can do this, and I can do this, and this change these all off to false, and that's how we start to develop. So right now, if we look at this, get out of here. All right, you see that there's sorry, 12 unit tests that failed. So I'm just going to basically shut up everybody and just keep one on. So I changed it on the flags. Now, each flag here, you can kind of see the flag. Here's the flag. And it basically enables the test. So there'll be another flag. It enables the test. So you can kind of see what's happening. And then if the task is false, then it's going to skip this conditional, and it's going to sit there and print that that test was ignored. So you can kind of see the code there. But all right, so boom, I recompiled it, and because I turned all those tests off, I just kept the first one on. Only the first one's on, so it's only one. I'm only failing one. I'm only focusing on one. So that's it. All right. So now let's go with this thing here, right here. So here's manager's failing, right? We can click here and say it's failing here on growth 2. So here, this takes in 2 parameters, so we need to match that. So in this case here, we just go into this and set up a constructor, right? And the constructor takes the int initial.
I think you already have that one.
What? I have that one? Oh, sorry, I do. Good. All right, so here it is. And so now all I'm going to do is start to fill this in. So here's my constructor, and a good practice is always to initialize your data. Data is public just for unit testing purposes, but you prototype in public and then you later crank it down. All right, so here we are. This is it. Let's see, let me see if I can move this there. Okay. First, oh man, you know, there's buttons you just no, not this. This is so funny how what they think is useful buttons.
I thought there was like Control I or something that allowed you to just fix all
These
the
buttons rock.
indentation.
Look, watch this. You know, this is boom. I mean, this is
Oh,
it.
those are fun.
Yeah,
What are
and
the
then-
hotkeys?
Yeah, you can do the hotkeys, but the problem there is you got to remember the hotkeys. You know, this. So that's vertical select, which is like insanely useful. And here's your delta grow. Then your total number of nodes is your total number of nodes you'll have in here. You'll eventually figure it out, but initial. Reserve. That's good to finish. Reserved. Active. And this is off the races. Oh, arrow. Sorry, wrong language. You know, I pass this. Is this correct? No, it's better. Now, if your format's all kind of winked, you know, all over the place, you know, there's and you just start discovering and looking through the stuff, but there's format document, and everything's right back up. All right, and then you just start to turn on the next test. But since we fixed this, right? So compile it, it runs, right? I'm happy with one test is passing. So then what I would do is I would go in here, hit clean me. All right, and now go to Perforce and make sure with the Perforce here, you had done your homework here where you had the preferences where it says on logging, the first 2 are set. And then the other thing is on your workspace, edit workspace, advanced tab, there's down here, remove deleted directory and revert unchanged file. These are the 2 you want set. And then now you can, anytime you do something, you can do it. So now you just submit, and any file that was submit, boom, it's there. And then this is your verbose, what had happened. And you can see right here, it says like node.cs. I didn't change, so it gets reverted. All right, and then I just rinse and repeat, check out again. Right now, let's say, and I'm working on a workspace. If you remember from Optimize, I always tell you from Depot, But here I'm telling you workspace because you're going to add and remove files. So you want to be in the workspace directory. But it's dangerous because you can accidentally check in too much stuff. So the thing here to do, let's create a file. So I checked everything out. Go in here, and now let's create a file. And what I almost always do when I start adding files is I just prototype it out. So here I'm going to add a file. So I'll add a file. So under here, just right click and say add CS file, new item. All right, class, and I'll call it D-Link. All right, there it is. First thing to do is kill that stuff, right? I like to see, my limits here. All right, so there's my my class. I'm going to just put in here really quickly. Public next public previous, and then then I'm going to sit there and inherit from node. So I'm going to say node inherits D-Link, right? And right. So let's see what I threw up here. Is less okay. So the problem is I didn't do D-Link. The class itself should be public. All right, compiles. I'm going to look at my manager. So here's my diagram. So anything .cd is a manager. I mean a diagram. If you want another diagram, you can just sit there and say add new item. And down here, I'll say class diagram and say, okay, D-Link. So what I always do is I go D-Link. And then I just kind of hit myself over the head diagram. All right, so there's my diagram. And then what I'm going to put in here is like, okay, here's my D-Link. Let's drag it in there, open it. All right, and then like node, open it, draws my inheritance. All right, let's say that, I like that. So boom, I'm there. All right, so compile again, everything's cool. Run it. I did nothing, so everything works. Close it. All right, so now the thing I do right now is first thing I do is I do clean me. Because right now there's the .vs file, the .bin file that has executables, the OBJs and other shit. So just hit clean me, boom, all done. All right, now I go back to Perforce, right? And I just do refresh. All right, so now what I do is I do this tricky thing here. I just sit there and say, you know what? Rectify. So rectify, and it goes, okay, hey, you added these two files. Yes, I did. Reconcile, and it goes added into here. There's a little plus sign. And now I just go submit. Which you should probably just gonna have it just doing revert on change files. Boom. These are only files that change. Now submit. Added. That's it. And you just start rinsing and repeating and rinsing and repeating, and you can start seeing the numbers start to change here. Here's version 2. What's the other file here? Node 2. If you want to go crazy, you can look at this stuff here. So here's time lapse. Here's a graph, tells you created, then there was a version. If you want to go in there more, you can go time view. And here is the file on version 2. And then you can go back and here's file 1. So 1, 2. You can see the lines are changing right there. You can go with who wrote it, history, all this other good. So there's tons of stuff in there if you just want to explore. But that's it. Just check in, check out, check in, check out, check in, check out, check in, check out. What I don't want to see is all the numbers exactly the same. If I see 13, 13, 13, 13, 13, that means you weren't reverting the files. There's no way you're changing every single file, every single check-in. That's it. To start adding there. You're not going to find yourself changing framework or this. Those are no touch. Tests are you can in tests you can. Oops, let's check this out. Check out what's this here. All right. So now some people have hooked up Perforce into the Visual Studio. I've never done that, but a lot of people like that. This way you can right click and check out or check in, but I do it all manually. So here, so here's my D link I added. You know, and here's the node I added, and I can start going from there. Check out this, and just keep building it out. That's it. So you're gonna be adding files here. Don't add the extra files. Don't add the OBJs or anything like this. If for some reason you did, so I'm gonna add it as a mistake here just to show you how to undo it. Perforce, you never ever, nothing's ever deleted. It's always on the server. So let's say you added a file called dog.tga today, and then you delete it tomorrow, and then a year from now you're going, hey, what was it on January 19th? It will come back and grab and restore the word dog.tga. So nothing's ever deleted in your Perforce directory. It's just marked for delete. So let me show you what happens when you screw this up, right? Compile it all, do this. Everything's there. Now it has all these extra files. Like a stooge, you just go, Perforce, and then it's like, somebody told me to use add, and they use add, and they bump, then it's add just a shit ton of stuff, blah, and now you're screwed. You got bin in here, you got OBJs, you got all kind of weird things in here. And the tell is, obviously you have this extra files, but the real tell is when you go into your project and you double click it, and then you try to run it, it's going to yell at you. And if you find this yelling, you screwed up. So here, of course, it worked. There we go. And you're going to start getting some weird errors like this and stuff like this. All right. So let's pretend that that's the case. You checked in all these files. There's too many files. You screwed up. Right. What you do is just make sure you have nothing checked out. Get your program on your machine working. So just run clean me. Run the clean me. Okay, they're gone. Now this is what you wanted. Go back to Perforce, refresh, and then right click and say reconcile offline work. And it goes, hey, all these files you accidentally checked in. So you can see the files that were accidentally checked in, exe, config, pdb, all these temporaries. Reconcile, boom. And it goes, those are all deleted. And so they go, boom, bye, hi. And now no hit, no file, everything's back to normal. So if you screw up, you can just hit clean me and then do a rectify and you can fix it. Just ask questions in the Piazza, we can get you through it. All right, so does that help a little bit for how to kind of start to develop on PA1?
Yep.
Okay. I saw a lot of threads where people were kind of getting confused. All right, so sprint 1 is brain damage simple. Here is sprint 1, I think, and it says graphics test. And what this is just doing is I just want to make sure that you have a working environment.
There's a bit of irony when we say working environment and then the program throws an error.
This is
Well,
Adobe.
Adobe throws an error.
Yeah. So Adobe, which is really heavy for something simple, right? All right. So what we have here is just so this is the sprint, and you're going to just follow the instructions, and instructions down here are really simple. Just get the game compiling, and make sure everything else is installed correctly. That's it. So what I want you to do is copy the Space Invaders into your sprint, checking in. then capture the video of the game running, and then record in there, your name, this is sprint 1, and then tell me like the best movie you watched the last 3 months, and that's it. And then check that all back in, and put the YouTube link here. It has to work. It can't be private. It has to be public. And then to verify the build. So how do you verify a build? There's instructions here, I hope. In Piazza, did I do it? No. Okay. Yeah, I did. It was on our Perforce. Here it is. So here's how you verify your build. Right there. All right, so I'm going to show you how to verify it really quickly. So let's say my PA1 is done. I'm happy with my PA1, it works. So first thing I do is I have nothing checked out. Nothing's checked out. And then I just go to Perforce. Go to my local machine, fire it off. And then run it. Whatever grade you get right now when you run it, that's going to be the grade you're going to submit with. So right here, I got 1 passing. Cool. I'm happy with that. All right. So now exit. All right. So now clean me. Okay. So this is, I like this. I like this submission. Everything's good. So now what I'm going to do is go to PA1, and then what I'm going to do is copy it, paste it, and let's call it something, safety. So this way, in case something really bad happens, you didn't lose anything, right? All right, so there you go. You got the safety. Now, the next thing you're gonna do is gonna go in here and delete it. And I have version control, so virus scanner, so it takes a little bit for mine to go. But what we're gonna do is go to depot directory, refresh. All right, let's hope that give me enough of time for this deletion. You bastard. DePaul added a kernel checker that checks exes while it's running in the background. And so sometimes the result is you can't delete your directory as fast as you want to. It will, come on, you'll delete, baby.
We'll let you rename.
No.
Oh, nice.
If you can't rename it, you can't delete it. There you go. See, there. Is it? And the IT weenies said, or IS weenies go, it has no effect in your day-to-day behavior. I'm like, yeah, if you're using Word, but if you actually do programming it, it sucks. All right. All right, so here it is. I just copied it, called it safety. All right. So now what I want to do is see what Keenan's going to see. So I go back to my depot, refresh, click PA1, right click this and say get revision. Now latest, get revision. There's a little button called here, force operations. Click force. And what that's going to do, it's going to bring everything down again perfectly what I was on the server. So boom, I get it. You can see all the files here are on the, came down. Now, if I like it, I just go in here and I do nothing and just double click solution. And then build and run it. And if I'm happy with this, I'm done, right? So that means I like what's on the server, right? So then my next thing is, now I want to do is update my PA1. So I'm going to go into Perforce. And now I'm going to select View, Submitted Change List. Again, this is all online. What you're going to do is just drag your PA1 directory on the depot side as a filter. Boom. And there you can see all the timestamps of our changes, right? So, sorted in the biggest number so you can see the biggest number. So there it is, the biggest number. This is my last submission, right? And it's 17481, right? So what I'm just do is check it out. Check out the oops, I'm gonna just check out the PDF. There's a PDF, check out. So here's the PDF, right? And then I look at the largest number here. So I have to sort by PA1, and this filter tells you your current user, current name, and then PA1 is a filter. So sort through this, take the biggest number. In this case, here is 127,481, Now go to your local drive, click your thing, and now 127,481. Did I verify the build? Yes. It runs in debug? Yes. It passed one test. You know, eh, right. And did it? Am I cheating? Yes or no? Your name, and that's it. Save. And this number here, 127,481, should match the last one here, 127,481. And now I'm going to submit this. I hit save, so then I can close it. Sorry. And then submit here. And that's how you verify and submit. Now the PDF has, everything's filled in. I know what the latest version that you did. This is just a safety. I'm going to grade the latest stuff, but this is just, if something catastrophic happens, we know that you said this number worked. So then we can go investigate. Questions?
Is there a way to get the change list without having to do like the first step of like deleting the, of making a copy?
No.
and deleting
The
it?
deleting of that is to verify what you have is up there.
Oh,
So
okay.
here's what happens, and this happens too frequently in this class. It all works on my computer, right? Because you added a new file here. You added a new file. Let me just say here. You added a file on this thing, but you didn't check it out. So you added, D-Link manager, right? And everything's working on your machine fine, like kick ass, right? The problem is when I grade yours, all I see is what's on Depot. So now I go look at Depot and like, you know what? I don't see D-Link manager. So I just grab this. I grab all the students at once. I grab it, and it's like it doesn't build. So that step is to verify that what's on the server is what's on your machine.
Okay, then to get the changes, you're just supposed to drag the folder to the filter because I do
that's
that and I
good.
don't see the change list.
From Depot.
Yeah, from Depot.
You just go drag it over and boom. All right, so let's just do that.
Mhm.
Who's this speaking?
Crystal
Crystal was.
Contreras, CONT,
There.
that one.
Yeah.
Yeah.
So here, boom. This. Now you got to make sure that this is all right. So it's not the current user. No. It's not the current workspace. There it is.
Oh, okay.
Yeah, you got to have the right user and the right workspace.
Okay.
Generally speaking, you can say current because it's your machine, right?
Yeah.
But so yeah, in this case here, it'd be 127, 160.
Thank you.
Yeah, and then yeah, and see yours is going right because there's not 1,000 of files checked out and checked in each time. So yeah, that's looking good.
Perfect. Thanks.
Okay. All right. So that's Perforce check in, build that stuff out, kind of get you guys up and running with that.
I have a
yes.
question about this sprint one. You mentioned that we need just to record a video and post
Yes.
our current Space Invaders
Yeah.
folder there. If I
Yes.
already have some changes in my Space Invaders folder, is that fine? Can I just post it like that, or you prefer
Yeah,
the original one?
It's fine, but the question is, what were you changing?
I was just trying to add the managers.
Okay, yeah, you can do that. That's fine. Just each sprint is just a full deep copy. So when the project's over, I expect to see sprint 1, sprint 2, sprint 3, sprint 4, sprint 5, sprint 5, final, and that's it. And so I can see the steps as you get there. So yeah, if you're working on it there, but keep copying and do not work in the same directory. So once you get something working on sprint 1, you're going to copy it and move it over there, and it's going to call sprint 2. Every week it'll be a different number.
Okay.
All right. So let's go back to a couple things here. All right. a lot of little things. I want to make sure we're on the same page here. All right, so first thing is inheritance, right? Inheritance versus interface. So you've probably seen you, or if you take in Java, you've probably been on the interface environment. So let's just play interface game for a second here. Let's say I have a class called car, right? And then I have an interface A, right? And let's just say that it has 3 methods, right? And then I have another interface here, call it B. Let's say there's 4 methods, right? So now when I instantiate car, what are you supposed to do? Well, you're supposed to put all the A methods. 4, there's the B methods. And then whatever, you can add additional methods and data for car, right? Is that making sense so far?
Yeah.
Do you guys go through interfaces in Java?
Yeah.
Okay.
Okay, so A is a method and B is a method within car, correct?
No, A is an interface, B is an interface. Each interface has 3 methods or 4 methods,
Oh, okay, thanks.
right? So now let's say we have another class. Say this class is called boat. So there was a question last week, and chime in if you were the person asking the question, but I know a couple of people were asking, why aren't we using interfaces? Why are we using inheritance? I think it was a question. That's what I'm trying to answer right now. All right, so let's say this class here has A. So there's 3 methods associated with A. Then we have C. And C has 7 methods. I'll just put 7 here. 3. All right, and then we'll say D. D has another 4. Okay, so now in your boat class, you have to do the 3 methods for A. You have to do the 7 methods for C. You have to do the 4 methods for D. And then what other additional methods you add just to the boat that are, oops, just to, keep missing it. Whatever methods there to boat. Okay. So now let's say we have one more class. We'll call this class plane, and it's going to have an A interface. There's 3, and we'll have a C, which is orange. C, which is 1, 2, 3, 4, 7, and we'll have, let's say it has a D as well. Okay. So now inside of this class, we're going to have 3 methods of A, 7 methods of C, and then 4 methods of D, and then, maybe 2 methods to the plane itself, plane, right? So there you go, right? So let's be very honest and not play games, but let's say, oops, how we would really implement this, right? All right, so as you can see here, on plane, you have 3 plus 7 plus 4. You have 14 methods that were described because of the interface, right? So you have these 14, and then you're gonna, maybe add a new 2, right? And then here you're gonna have 14 methods because of the interface. And then, in case here you added, 4 new ones. And here is, 7, and you're going to add, let's say another 4 here, right? So what's happening with A? Let's look at the A class for a second, the A interface. The A interface, let's say what you're doing is these 3 functions or 3 methods, right? But if we're really honest with our stuff, if it's the same methods you're going to use, and like, oh, well, the method I use for car is the same for methods for boat, I'm just going to take this code, I'm going to cut and paste it and put it over there, and cut and paste it and put it over there. Do you guys see how you would naturally do that? If it's going to do the same function, why won't you just cut and paste it, right?
But can you just implement it into like in the A interface instead? Like have the
No.
have the implementation in the A.
No, that's why you
Put
need
it in a
inheritance. That's why
Separate,
you need-
yeah.
That's why you
I was
need
gonna-
inheritance. So I'm basically giving you the justification why you need inheritance. So here, the C, you have cut and paste seven methods, right? And then, you know, here's this, and then let's say, you know, here's, oops. Here's D, okay? So most of the time you're going to more or less cut and paste this, but here's where it gets really weird, right? Let's say, try to find the right color here. I guess I used enough of colors. Let's say this function right here in this method here in A, you screwed up. There's a bug in it, right? Guess what? You have the same bug here and the same bug here. So now you have to go change it in this location and change it in this location and change it in this location. Say you have but let's say this. Let's say you you find a bug. It was a bastard to find, and you find a bug right here in this method. Like shit, there's a bug, right? And you fix it. So you fix it, you rework it, and you fix it, right? And you're like going, oh yeah, I got to do the boat. So you fix it, right? But you forgot the plane. You just forgot it because your code's not running it. It didn't crash. Now you're seeing the maintainability issue here is that with interfaces, I don't want a class that has 25 methods or 7,000 methods or 50 methods. I drew this just because there's 3, 4, 7, but this might be 20, 20, 15. And all of a sudden you got a bloated class, a class that has so much functionality in one class. The second problem is it's the cut and paste syndrome. You cut and paste, cut and paste, cut and paste, which kind of makes sense. But then at the same time, when you find a bug, you got to now fix it in n instances of it. If you use that interface 7 times, you have to fix it in 7 locations, right? So an alternative to this is what we do in C++ is that we would sit there and say, okay, well, we would sit there and say, okay, here's an A class, and then here's the B class. And what we would put in here is we would make these things virtual functions. So virtual function 1, function 2, function 3, all virtual. And we have over here the virtual function 1, 2, 3. So there's 4 of those.
So basically we change everything to abstract class instead of interfaces, right?
Not abstract class, right? And so now this is car. And what happens is just by inheriting it, I get A and B completely. And then if I want to add more methods, I just add more methods. Okay. So now when I sit there and do the what's it called? The boat. There's boat. You know, it's using class A, you know, class C. And this has 7 methods. And class D, this has 4 methods. I get all those methods, and now you know, that's it. So my boat class is very small. My responsibility, I inherit all these additional methods, right? But the catch is this A class, they're the same class. So when I have a bug, let's say I have to fix this guy here, I fix it once and everybody gets it. So what I really have here is, this is what I draw out, this multiple inheritance. I really have this. Here's an A class. Here's a, here's a B. Here's the C. Here's the D. Right? These all have methods. And then when I sit there and say car, I'm just, driving from these two guys, right? When I say boat, I'm driving from these three guys. So then when there's a bug in, let's say B, like there's a mistake in this class here, I fix it here and suddenly car is fixed, boat is fixed. No matter how many classes, there's some other class over here, bird, this class is fixed, right? But so the first thing is, if I make these inherited classes, I can get that benefit. The second thing is, when you do a class, you make these things virtual methods. And this is kind of your default behavior. So this has your virtual method 1 and 2. This has your default behavior. But if your drive class needs a different behavior, so let's say method 1 is wrong, well, it could just overwrite method 1, and now it has different behavior. So by making something virtual, you get default, right, behavior. If you sit there and say, this class beneath me, my drive class, I have no idea what to do in this function, only that class knows, then this is when I make it an abstract method. And so then I overload that abstract method. So this says you have to implement it class below me. Virtual one says, you can overload it if you want to, but if you're okay with what I got, use what I got. And this is going to give us the most reusability. Does that make sense?
Yep.
So now here's the problem. In C++, you can do multiple inheritance. Trying. You can do multiple inheritance. The problem is you can't do that in C# or Java. So this is what you do. You just stack it. So this class here, class dog, has class A, B, and C functionality. This class dog here, which is C# or Java, will have A, B, and C functionality. But because Java, C# do not allow multiple inheritance, you have to do it this way.
Do you know why they removed multiple inheritance?
Yeah,
it was
because
in
they thought customers were too dumb. I seriously, that was the transcripts. Like, people screwed up and they're too dumb. Yeah. If you took optimize, we go into this a little bit there. The problem here is if you have a method called we'll say find here, they have the same name, find here, then at this level here, do I call this guy or do I call this guy? It doesn't know.
I think you can tell it which one to call.
You can, but I'm saying this is, I don't want to
But
get
not
into
by
multiple
default.
inheritance with you, but So there's a thousand ways to get around this here, full scoping or unique name set. So, but Java architects removed it because they thought there was too many problems with multiple inheritance. So anyway, so I just want to kind of show you all the way back here. You'll see interfaces, right? In textbooks and in material, you'll see this whole interface area. The problems with interfaces are these classes become huge, absolutely huge, because it has to implement every single method there defined in the interface. When you have multiple classes, you got a lot of cut and paste. When you have maintainability issues, because if you change one method, you got to make sure you change it in every single location where that thing is. So this breaks the drive principle and also bloating principle where the classes do too much. By flipping it into inheritance model, you can give a default behavior or default functionality by using virtual functions. You still can override it. So like, well, you know what? A car is not a boat. So I want to have different behavior between a car and a boat. I can overload that one function that's giving me trouble. Or I can even specify it directly by going with an abstract method, saying, okay, the derived class has to implement a unique implementation for each of their things, right? So we have most flexibility with inheritance. Okay, the principles I just talked about, there's one principle called dry. Oops. Dry. It's, don't repeat yourself. Which means you should have one class or one function does it and everybody else uses it. So let's say you had one function that does square root. Every single class in your system should be using that one square root. So then if you fix the bug here, everybody gets that benefit. You don't want to have 2, 3, 4 different implementations of square root. You want one and everybody calls it, right? So dry. So inheritance model breaks the dry principle, which is absolutely horrible, right? The second thing is, I call it kick the can, or you're only responsible for what you touch, right? So if I have a class A, a class B, and a class C, right? And let's just give this simple variables AX, B, Y, and C, Z, right? Right. When you instantiate, if you instantiate A, you just get the A variable. If you instantiate B, you get all of B plus all of A. And if you instantiate C, you get everything going up, right? So you instantiate going up, right? But here's the catch. The A constructor can only set that variable. The B constructor can only set the B variable, and the C constructor can only set the C variable. So if you want to initialize the class, we'll say we want to initialize class, we go class C, PC equals new C, and I want to pass in 1, 2, 3, and this is going to be the X, Y, and Z, right? So let's say I want to do that. How it would work in this model here is every layer is responsible for its own data creation, initialization, and actually methodology and functionality. But let's just go with this creation. So which we do here is this. Oops. I want to initialize this, right? So I'm going to get here C, and it's going to take in, X, Y, Z, right? But I'm only allowed to touch the Z component, right? So in my constructor, I go base, you take X and Y. I'll handle C. So CZ equals Z. Now that kicks the can up to B. So the B thing now just takes X and Y. And inside the B class, all I'm allowed to do is touch the Y. So, you know, BY equals Y. And now I'm going to go base, take the X. So it kicks the can up. And now it's A takes in X. And oh yeah, I can handle that. AX equals X. So if you can see this is that each layer is only responsible for its side, you know, for its steps. So here's A is only responsible for A, the B is only responsible for the B, and the C is only responsible for the C.
Is base a C# keyword?
Yes.
Okay.
Oops, I did the right color here.
Could you change the order of when it gets kicked up the can? Like, could you do BY first and then call base, or does it have to be first?
Well, ideally, how you're supposed to do this, and you should honor it, it should grow from bottom up.
Okay.
You initialize from top down and you destroy from the bottom up. Just think of the stack, right? So technically speaking, A should be initialized first. So when you go into C, right, it goes to here and then it goes quickly, it goes work to B. Then it goes, oh, that's going to go to base. Work. And this is the first line of code that happens. Then it comes down, it's done with that job, right? Then it's going to do this is the second, and then this is the third. And guess what? 1, 2, 3, it's going, creating going down. So separation of levels or responsibilities, separation of data. And that's another thing that, you know, I call it kick the can. Just do what you're responsible for. If I'm in the B class, all I'm responsible is for the B variables. If A needs something, I kick it. I call its function. And let some function here deal with A variables. Right? So all you need to know is, did you do your stuff? Give it to the next person.
Does it implies to updating the variables as well?
There's no accessors. No, this is all inheritance. You get access to everything. You could be a bad citizen, right? You could. And this is what most people do. And I just want to scream. You could do this. C takes X, Y, Z, right? All right. AX equals X, AY, BY equals Y, CZ equals Z. This will work. But guess what? This layer here now is grabbing the variable there. And it's also grabbing the variable there. You just broke these layers. These layers are supposed to be sacred. So one of the things to kind of get into everybody's head, and it's really, it took me years to kind of get this concept. And also I'm like going, well, shit, why don't they teach it this way? There is no such thing as rules in programming. You've got access to all the data up and down. You know, C++ is even worse. You can just cast it to anything and get around it. The whole idea of, you know, this data is controlled by this variable and just that is a convention. It's not a hard set rule. So here, the convention is each class controls the data for its respective class. And if you find yourself in the B class for whatever reason, so you find yourself in the B class and you need to change an A variable, you don't change the A variable, you delegate it and let the A variable, A class change for itself. And the more you kind of buy into this, the cleaner your code gets. It gets bigger, but it gets cleaner, right? All right, so this is the first thing I wanted to talk about was that. Does that make sense so far?
Yes.
Yep.
All right, this one's a weird one here. It's just like two things that kind of come up. Coding conventions, right? And so basically code style. It's TYLE. Okay. Code style is if you ever work at a company now or will work, when you start talking about your coding style, this is a religious argument, right? You might as well be arguing whose God is better than whose God, right? You might as well be arguing religion because it's just that polarizing. But I'm going to kind of seed you for a concept here. If you did if, and then using the editor, it would kind of do curly brace. You can do a couple semicolon statements here, curly brace, else, curly brace, couple statements, else, right? And the catch is if you just draw a big marker across it for each line, you have this indentation style, right? And so there's this one. Now let me show you the one I use. If then I drop it down one, and then all my statements, else, curly brace, statement, here, right? So now when I do this, so now if we look at this stuff and to pretend there's no code in there, no black ink, just colors, right? Square this up a little better. You can kind of see just by visual indentation, right? On the one here on the right, we'll call this number 2, number 1. Number 2, you can say there's some statement, and then this crap is bound to that statement. Then there's some statement, and this stuff is bound to that statement. Here, it's not as obvious because you have line, line, then indentation. Line, 3 lines, and then indentation. There is a compressed format that some people use, which is, I think, hard to read, but is that they put the trailing curly brace there, then they do code, then they go else, oops. They put the curly brace at the end of this, and they go, oh no, a lot of times we do this one, else. And then curly brace. And so this style here is minimal line approach. And and sometimes this guy might be over here. I've seen both. Looks a little better up there. All right, so again, this is nice because it kind of does the same thing. This statement binds with this statement binds with this. And so just for a visual flow, you get to see this. And this stuff here, this is out of Code Complete. And this is a book, Code Complete. And he talks about the different styles. But when you're looking at hundreds and thousands of lines of code, you quickly have to identify where's the indentation, who owns it, who's responsible for it. The thing you don't ever want to do is do conditionals or whatever, and just do your statement. Then you do another statement. And what happens is this is the sucker punch move. This guy is bound to this. This one always gets executed, always. So this is why you always put curly braces on everything, no matter what. So then, it's clear that these two things are tied to it. Or if it's not tied to it, you would just still curly brace and then put your new statement there. Always, always, always use curly braces. A lot of times I'll even communicate the else. And for complicated ones, I'll sit there and say do nothing. And this communicates that I consider the else condition. I decided that that's a do nothing fall through. So just give me a little bit of convention styles, because I think as we code on, it's going to start becoming more important. So whatever style you like and use is fine. I just wanted to kind of expose you to a little bit of this. All right, so let's go back to last week on the memory system. I'm sorry, not memory system, the manager. We had, we had the manager base, and then we had texture manager, right? And then this would connect to a list base, and then this would connect into a list manager. And in our case there, that would be the D-link. Oops. So I think this is node on, what did we call this one? Something base, node base.
Node base, but that was kind of confusing with the node class and PA1,
Yeah,
I think.
I just generically call all these things nodes, but whatever. Anyway, whatever you want to call this, call it base, doesn't matter. All right, so we look at this stuff here, right? And we're pretty far along on this, but there's one thing I want to make sure everybody knows. Why do we have a wash? What's the purpose of the wash?
To reset the object to its neutral state.
Right, so this is kind of acting like the default constructor. So basically, when we add something to the list, it's sitting on the list, but when we pull it off and put it on into a different list, we want to wash it. And this way there's no debris or remnant data living on it that can cause harm, especially like those backlinks and stuff like that. So the wash is basically our default constructor, and that it's really important that we put things in a neutral state when we move stuff back and forth between different lists. And as we know that this whole picture here, see if I can copy this correctly. Um, all right, so then essentially we have this. One is active, one is reserve. So we have this thing kind of replicated. So we really have two complete lists. We kind of have the complete active list, and we have the the complete reserve list. So we have that, and because we're moving this node here from active to reserve or reserve to active, we want to correct all these links here, all the connective links there. So that's why the wash is really important. All right, so now let's start looking at code. All right, so last week we started talking about iterators, and the iterators we're dealing with. There you go. Sure. All right, so I'll have to go by slides. So the iterator basically just has next, there we go. The iterator has first, next, is done, and current, right? And so the critical thing here is your iterator class has a first, a next, and is done. These are all abstract methods. So if you derive from this, you have to implement and overload each of those functions.
Overload allows you to use those functions.
Yeah, so this is kind of the cornerstone of a lot of the patterns is this base class here. So this base class is the contract. And then it sets the rules, right? So it sets the rules, and the drive class has to obey those rules. So the rule here is you have to implement these three methods: first, next, and is done. And how I'm going to enforce that rule is I'm going to make it an abstract method.
Do we need a current on that list too?
Current's optional because
Okay.
You can get a current if you want. That's totally optional. So this says there's the optional. I haven't used current much, but you can totally do that. And I'll make that a virtual, because virtual says you can give a default behavior. So you can sit there and say, do nothing, right? And then if you wanted to, you can still overload it. But basically, everything in your drive class is, your base class is the contract, and we're forcing that behavior on the drive class, right? So if you have nodes that are linked list, right? This will be your first. And then we say, when you're pointing here, it's like, okay, go next. Next is going to go here. And then your current would also be this one, right? Right. And then you say next, and then now this is your next. And then this is your current. And the next, this will be your next. And then if you go next, it doesn't return anything. The is done flag is set. It's true. So this is kind of how this thing works. It's just going to keep giving you the next one. So if you think about it, it's pretty, if you kind of look at a linked list, it's what you think of is pretty straightforward. And the iterator almost seems like kind of useless. Like, okay, of course we start at the head, right? And it was like, next, give me the next one. Next, give me the next one. Next, give me the next one. Are we done? Well, did it terminate, right? So we're just making a kind of generic interface. The reason for that is this, is if we have okay, now we have a tree. I want you to touch every node of that tree once. And I want you to just add 10 to every node, right? So your iterator might sit there and say, oh, you know what? This is first. Then next goes here. Next goes here. The next goes to here. The next goes to here. The next goes to there. And next goes there. And next goes here, 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 here. And then we're done. And so we can take a tree. And basically, in this case here, this is a depth first traversal, right? But we can implement this tree in terms of an iterator. And all I have to do is some poor bastard wrote the iterator, right? And then it's, you know, this is an iterator for this tree. Right, so they had to implement all these different things, overload next, overload, you know, first, right? So somebody had to do this. So, you know, some poor bastard had to do that. And then all we need to do is just go, okay, fine, thank you, tree. Give me the first node. And it goes, okay, here you go. Here's the first node. All right, give me next. All right, I'll give you this node. Give me next. I'll give you this node. Give me next. I'll give you this node. Give me next. Next node. Are you done yet? No. Give me next node. Are you done yet? No. Give me next node. Are you done yet? No. Give me next node. Are you done yet? No. So the customer just goes there and is like, are you done? Yes. Stop. The customer doesn't know it's a tree. It just goes next, 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 next is done. You know, I'm done. And no matter how complicated the data layout is, right? So let's say you had this. Let's say you had a linked list. And the data was the keys, right? So you have key 0, K1, key 2, key 3, key 4, key 5, key 6, key 7, key 8, right? But if you're going to sit there and talk to the iterator on this, so this is, you know, you have some iterator, right? And this is some, you know, custom, you know, data structure, right? And then you just go, okay, give me first. He goes, okay, here's K, give me next. Okay, here's K1, give me next. Here's K2, give me next. Here's K3. Well, whoa, what just happened there? I went down the list here. I went this one and this one and this one. Then it says, oh, next, there's no more here. Go to the next, go to the next node, grab the first one. So all that stuff's buried in there. So I can make my iterators walk any kind of complicated layout, but it's presented to us in a nice linear fashion. And that's why iterators are good. It's not so much that, hey, we don't know how to walk a linked list. We don't even care about how the linked list is laid out, or a tree or a hash map or arrays or whatever. We access the data in the same method, same way. Right? So when we're talking about design patterns, sometimes you want to look at this stuff. Sometimes, you know, besides the stuff that I do in class, you might want to explore yourself. So you go to the website, and it's do factory design patterns. So here is there's do factory design patterns, and basically what this is, this website has a lot of design patterns here. They're not the best implementation, but basically what they did is this product they make is they basically make a library that you buy that's supposed to be really fast. And it has the design patterns implemented really fast. Well, actually, in reality, they're not that fast. But what I like about this is it has the design patterns. So here's a quick link of design patterns. So let's say we're talking about iterator. We just scroll down here to iterator. And now it tells you the frequency of use. It's very frequent. Here's the UML of this. And it basically says, you know, okay, first, next is done, current, and then it's implemented. But here's where it's useful. It describes everything. And it has code. This is where you can start to experiment. I want to show you how to do that. So we just cut and paste the code. And now, test bed. So, oops, I did this out of order. Let me move a test bed over. So if you want to see and experiment with other patterns, please do. Or if you want to see it in a different way, because maybe my style isn't, working with you. This is a technique. So cut and paste it, and then go in here, program, and let's see what this code looks like. Let's start some advances on. Let's put paste it right here. All right, so here's this. All right, so let's all right, so I just cut and paste it here. And now we can just do a quick run of this. And you can see here it created 4 items. It's going to sit there and call the creator. It says, okay, give me the first one to do this. And you notice right here, it says, okay, print this stuff out. So let's see. Here's the display. Let me bump up the settings here. Properties. All right. So a lot of times they'll sit there and do everything onto the prints thing. This is why I like to use the whole diagnostics, because then it becomes in the window, because that's so annoying. So I use the diagnostics. So it'll be debug dot write line, and then just quick search. So you see a lot of bad habits happening here. I think that's only right. Here's. Okay, so let's do this again. What's nice now is there's your window. Now you can kind of see it there. All right, get the first item. So we get the first item goes boom. We get it. It returns item A. Then it says, okay, write the item. So there's A, get next, B, C, and D. All right. So this is, it just shows you this thing is working, but technically speaking, even their code is kind of wrong, because it shouldn't be until item is null, because you should not know it's null. You should be using here. This should be so even their demo code was wrong. I is done is not done, right? Now and that's the correct use of this, right? Because you shouldn't know that there's a null. And you can see that I'm stuck in this loop. That means the is done is not correct. So I kind of discovered a big thing. So there's their contract for the iterator, right? And if we want to, let's do that. Explorer, then we can just sit there and quickly add a class diagram. right? And so now in here, I can sit there and say, okay, I'm going to add the iterator. Oops. All right.
I think from expanding program.cs, you could drag it over to class diagram
That's
one.
yeah, I'm gonna say I know there's a trick. Yeah, iterator. There we go. All right, so get to the diagram here, iterator, boom. Self-built. Yeah. Might be see why it's not working. Anyway, it should work.
Is it the read-only thing?
I'm not sure. It might be that this is all nested. This is all a nested class, and sometimes the diagrams are. Oh no, that's not nested. Let's do here. Add. No. There you go. Aggregate. So here's the iterator. And we can see these are all the abstract methods. And then here they are all overloaded. And then here's the concrete iterator. And this is going to be implemented here, right? And then this points to the associations. And this is where generally their stuff falls on its face because their examples go into generics, which we are not going to use arrays or generics in this class. It has a load of problems, but you can see, look at how many interfaces this adds. So anyway, but it turns out there is done, looks like it's problematic. They're just doing an account is how they tell if it's done instead of tell that the no, that should be right. Is done greater than or equal to count. So why is my loop not working? Anyway, just want to show you that you can start this up and look at this. Obviously, I randomly picked the wrong example because this code has problems, but just wanted to kind of show you that. All right, so now let's go to source code.
I think it's because their next only adds up until count -1.
Yeah, I think there's some problems. All right, so let's start expanding the code now. So here's the game. Just cut and paste the game. And what we want to do here is start to understand the game code and start to make something out of this. Sorry. So here's game. We'll just run it. Right. So this is the screen right here. Every single thing that has an image on the screen is called a sprite. Why it's called sprite, I have no clue. So these are sprites that are moving around, twisting, changing, shrinking, adjusting, right? And this is all built into the library. So we have this, the library is Azul, right? So it's Azul sprite. And what I'm doing here is I'm creating alien, white, swap, stitch, a couple things here. Here's my speed. And I have basically three things: a sprite box, and a texture. Those are the three things I have. So a sprite is an image. It has a center point, and in this case here, it can be the bird, the angry bird, right? So there's a bird. So it has a center point, bird. And what you can do then is move the center point and by just changing its X and Y. So there's the position. If you want to scale it and make it tall, You can just go scale X equals 2 and scale Y equals 1. So it'd be twice, I'm sorry. Got this wrong. Scale Y, scale X. So it's twice as high. And you can also rotate it. So if you want it to be, and this be a certain angle of rotation. So there's this an angle. So what we can take as a sprite that has a picture, right? So a sprite will just have an image on there. It has a center point, and then we can sit there and place it anywhere on the screen. So here's the screen. And the screen is going to be 0, 0, just like old true high school math. This is your Y, and this is your X, and there's your origin. So you want to place this, and you place this here, let's say at, let's say this thing is 800 by 800. If we place it at 400, here it is. And then your sprite land right there. And you'll just see the picture that, so there's some transparency. So you just see the squid, right? If you want to move it, you just change its XY, and suddenly the guy moves, right? So we can move it, rotate it, and scale it. That's a sprite. Sprite. So then we have a texture. So texture. This is a little bit weird. This origin is in the upper corner, and it has a certain height and width. And what we're using is TGAs. Right? And you might have a picture of, let's say here's an alien. Right? And in there, you have, if you want to cookie cutter this alien out, you have a certain X, Y, width, and height. And that will cookie cutter that. And then on your screen, so here's your screen. X, Y. You specify it. Well, how big of a box do I want on the screen? So first of all, where do you want it located? So let's say this is 800, by 400, how about 800? Let's say you want it in the center, right? That's 400 by 400 is the center. How big do you want this box? I want this box to be 50 by 50. So it's kind of small. Come on. Right here. So the center point here, so this is at 400 by 400. That's your X and Y. And the height, say, is 50, and the width is 50, right? Then you want this picture to be painted onto it. So this is the sprite, X, Y, Z, center, right? And then we want this picture here to be painted onto this. So now it's going to be here. So what we're calling this is the image. Image is a location of the texture, and this is the sprite on the screen. So we can have an image that has many objects on there. So let's take a look. So there's this is a texture that has many locations here. And what is, if I want the green bird, I would just select the green bird. And here, so here at this corner here, it is, so, oops. So I don't know if you can see in the bottom corner, this says 346, 218. That's this corner. And then when I first select it, it's going to give me 100 by 81. That's the width and the height. So we have the corner, you know, 243, 131, and the width is 100 and the height is 80. So we have this. So green bird. Right. And so we have this corner here, it's 240, 180. I think I'm just going off of guesstimate. 130. Okay. $130, and then it's width and height. The width is 100 and the height is 80. And this is the image. And this is going to be in the sub. This is the texture. And the origin is in the upper corner. So now we want to place this on the screen. We first of all sit there and say, okay, for the sprite, what's the width and height on this? Let's say we want it to be a perfect 200 by 200. So width 200, height 200. Now we want in this location. Okay, this location is 600, 400. So it's X is 600 and the Y is 400. Now that bird gets drawn on top of this. So sprite is the original location on the screen. The screen is 0 times 0. And then the texture is a sub window. So you're going to cookie cut the sub picture from the texture and place it onto the sprite. So we look at this here. Here's the cookie cutting. Now let's look at the code. All right, so we have here's the screen, 800 by 400 in the clear color. So let's, all right, so.
Why is there just one single texture? Is it just to have like all of your stuff all in one spot? So you don't have to load more than one?
Yeah, so every time you reload a texture, it takes a lot of time and cycles.
Okay.
So it's a caching thing, but you can have multiple textures. So like here we have the aliens. Right? This is just a real rough thing. And then we have the birds. We could have one, we got many of these, but we try to put a couple different images there just to save space.
Okay.
you notice on this thing here, I have Stitch, right? Here's Lilo and Stitch.
Mhm.
And Stitch is a full image. So it doesn't have to be a subregion. It can take the whole thing. So here it takes the whole thing, Stitch.
Okay.
So it can be at any level, you know, it can be partial or full. But basically we're going to paint this picture onto a sprite. Right. So, so let's look at some code. All right. So I went through this last week, but when we do this, main starts the game, it hits run, and then we get into the game, and basically the game has initialize, which is the size of the screen and the reset color. So reset color right now is RGB alpha, so red, green, blue, alpha. So it's going to be mostly blue, but I can just go in here and change this, and I can change the color then. So there's, you know, now it's gray. I think I can shut off this debug window. Hold on a second. All right, later I'll figure out there's a trick to turn off this. I'm getting annoyed by this guy right here.
You can just leave it open and like make it smaller. That's what I do sometimes.
Yeah, I can totally suppress it out, but I have to figure out how to do that.
There was an option there in that screen that you were just now to automatically close when debugging starts or something like that.
Yeah, no, I'll find a way. I think I can have it totally closed always when it's running. All right. So anyway, here's the screen. You can add a title here, or whatever you want to call it. You know, sprint 1, and that'll go on to the banner right here. So there's sprint 1 in the corner, and so then here. Here's just a setup. You'll see here is like load up the textures. So here's the 3 textures: texture alien, texture Stitch, texture bird. All right, now draw a sprite. So we say, oh, I want a sprite. I want to say it's an alien texture. Here's the subregion of the texture, and then here is the location on the screen. So it's subregion of the texture and then the location on the screen. So there's 2 rectangles that we have to control. And then once you get a pointer to that, you can handle to that, you can change it. So we can change the X and Y. And then your thing is, what you can do here is you can just add certain X to it. And whenever you do, you add X or change the angle, whatever, you call update. An update flushes it to the hardware. And then when you're done and you update and move everything around, you just say dot render, and now it draws it. Okay. So now if I want to sit there, only render the birds. Now I'm only rendering the birds. If I only want the green bird on the screen, there's a green bird. So let's take this code and shrink it down a little bit because it's pretty bloated, and this way we can kind of understand this a little better. So let's shrink it down to 1 texture. And now what we're going to do in this class is we're going to start to add. So here's just the textures of the birds, and you know this word. Right. So here's just birds, and we load up just the bird texture, and we load up the 3 birds. And now what we're going to do is start putting organization here. So let's do the green bird. So let's get rid of this. So just green bird, right? And you're gonna have to experiment a little bit on this stuff. All right, so red bird, yellow bird, green bird. Okay, let's just really take a chainsaw at it. Green bird. All right, so what I'm doing with the green bird is I'm just moving when it exceeds the width, change its direction. So when it goes fully to the X, change the direction, have it go right. When it goes fully left, turn around, go, go back and forth horizontally, back and forth vertically. Right. All right. And then my draw, which should just be green bird. All right, so there it is. Let's make the bird bigger. All right, so bigger, I can sit there and say, you know what? Here's the size of the texture and this. So this right here, the second one is the sprite. So if I want it bigger, let's make it say 175 each. Right. So there's the bird. Now I could sit there and say it's born 100. So that's the width. So it's born this size. But then once it's born, I got a handle to it, right? So now I can go P green bird dot SX equals 3 P green bird SY scale Y scale X 3. And now I'm doing this. So we have the whole concept of it comes in at a certain size. So this one right here is the sprite. X, Y with height. And then this one right here is the texture. Texture sub window, or I call it image, which is its X, Y width and height. So this is upper left. And then this is center. So so this is position initially starts out at. So if I sit there and say there's no movement, it's going to be at 400, 200. There it's 400, 200. If I want to sit there, let's make it a little smaller. 400, 200. Now let's make it 400, 600. So now I'm just going to go north on the screen. So there's 400, 600. So I can control the position of this right here. So this is the position on the screen, the X and Y, and the initial width and height. So generally speaking, you try to get the scale, I'll leave it always at unity, but if you want to do scaling effects, you can shrink and adjust it as you go. All right, so there's a small guy, and then this is the size of my screen. Yeah, 600. So I'm right at the top. So let me move it to the center here, 300. Right, and then there you go. Okay, so that's in dead center. All right, so now if I want to move stuff, I can move. I can change the X, Y. So things I have access to. So let's look at what I have access to. So on the bird, it's a visible sprite. Let's look at a visible sprite. It has the XY angle, scale and angle. And then here's all the functions we can do to it. We can sit there and render it. We can change the color. We can change the texture and change the rectangle. Right. So there's some of the functionality we can do with this. So there is the sprite.
Angle is 0 through 360.
I
Or
think it's gonna be radians.
Oh, radians. Okay.
Yeah, it's radians. So yeah, angles almost always radians. All right, so this is just gives you, this is how we draw a sprite, right? And we have this stuff here. So now let's go through this and let's add that abstraction. The abstraction here is, we're gonna call the subregion an image, this whole thing a texture, and then we'll have a sprite. So we're gonna basically create these 3 different classes. So do it here. So now we're just going to start to abstract this. Okay, so now we have this, a sprite, right? And let me go through the pattern. So the pattern we're going to be using now is called the adapter pattern. An adapter pattern is fancy word for saying wrapper. So the adapter pattern, oh goodness. It's shooting to the wrong monitor. All right, we'll stay here. We'll stay with this. The adapter pattern here is basically, you're just, like, see right here, this legacy, this one in the corner here on the right. Yeah, I'm not sure how to swap the monitors.
Yeah, don't use presenter view. It's right at the top. It says monitors.
Where do you see that? Oh,
Right. Yeah.
okay. Primary. Thank you.
Okay.
New laptop, so still trying to understand my way around it. All right, so here's the adapter pattern. All right, and what we have essentially is, this is the original, right? And this is ours. This is our custom, right? And basically what you're doing is you're leaving the hardware. So generally you abstract this with hardware. So this is your hardware layer, and this is the one you use. You control that one. And then when you're ready, you take the data and you push it to the hardware. So this is a push. And what this does is it separates hardware from software. The reason for this is, when you are dealing with anything that takes time to update. So let's say I'm going to update my sprite. I'm going to say, set it +1, -1, +1, -1. I just keep noodling 1,000 times on X, right? Then at the end of the day, I'm like, okay, draw it. Well, if I keep talking to the hardware, I'm now sending stuff to the hardware back and forth, back and forth, back and forth, and I'm only going to keep the last one. So I'm kind of thrashing my data. So it's kind of like this. In compiler development, if you did this, if you go X equals 5, X minus equals 1, X plus equals 1, X plus 0, right? X plus 1. Then it goes, okay, print X, right? And you go, okay, well, now it goes from 5, it goes 4, goes back to 5 to 6, goes to 6, right? The compiler says, why the hell did you do all this work? The compiler just goes, you know what? X equals 6. So all this stuff gets compressed into that. Well, if you're writing to hardware and you sit there and say, you know what? My hardware, so let's say over here, here's my hardware. It has an X variable. And I'm going, okay. My code says, set this, no, set it this way. 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 So you're sending this to 5, to 4, to 3, to 5, to 5, to 1, right? Then you go, okay, draw it. Well, what's the last value here? X is 1, right? But meanwhile, this takes time. And so when you send stuff to hardware, it takes time to go across the bus. It takes time to talk to things. It takes time to convert things. And so what you want to do is never touch the final value until you're done and settled. So what we do is we create a surrogate object. So we basically create here's our sprite. And then here we have local variables X, Y, angle. And then basically it points to the hardware. And then this has X, Y, angle. And so we can have our game just be throwing this back and forth, changing the values left and right. X is 1, X is 2, X is 1, X is 3, right? Then at the end of the day, we go, okay, draw. And then when we say draw, that's when we go, okay, push these over once. So push X, Y, Z and angle over once. So it takes the last X, Y angle. Then the next command is now send a draw. And now this just gets updated with the latest value. So in this case here, 3, 5, 0.2. And now this is drawn and this goes to the hardware. So basically by having this as a surrogate object, as an intermediate, as an adapter, we're basically saving the costly push to everything. So think about this. If you were writing your application and you're writing X and you keep changing your data constantly. So you're changing to 5 to 4 to 3 to 5 to 6 to 3 to 1. You keep sending it. But instead of sending it here on your PC, it's sent each time to the internet, right? So this went to the web. And then here's your cloud value, X. Well, you send a 5, you're 4, you're 3, 5, 4, and so this takes time. At the end of the day, you're like going, nope, this is the one I want. I want 1. Why did you send over all this bandwidth traffic when all you really wanted to do is send the 1? So what you do is you basically send everything into this cache. You just use your cache and keep thrashing this. And when you're done, the last version goes across. The same way as when you write to a file. So here's a file. You don't actually write to a file. You write to a buffer and you keep filling this up, changing this data. And then when you call flush or close, that's when the data is actually written over to the file, and that's when it fills it in. So it's this whole idea that you thrash on a small bucket, and then when you're done, it gets pushed over.
Why might a whole bunch of values be sent in that one frame?
No, you're not, the right hand's not going to know what the left hand's doing. We're gonna have a lot of things moving on, right? But it's also to kind of make sure that we control the access, right? So let's say here, I think Robin was asking about the angle, right? So the angle. So let's say the angle that you want to deal with is degrees, because you understand degrees, right? You're not a weirdo like me who likes radians. So here's your sprite. And you start setting all the angle. You sit there, say 45 degrees, right? Then it pushes to the hardware. And this push as you convert it from degree, to radians. And then the angle here now is in radians. So an adapter will condition your data to move it over there. Adapter will also, this is the adapter. The adapter also insulates you from talking too much to slow things or to resource sensitive things. So the adapter can be, I like degrees, but the hardware wants radians. So I can keep everything in degrees. I can be fat, dumb, and happy liking degrees. And then when I'm ready to use it, I do the one conversion over and adapt it to match the hardware. I can use this to save unnecessary writes and hardware hits to it.
So is that just like a preventative in case multiple objects are trying to talk to the hardware?
No, you want to control when that thing's updated. When is it touched? When is it updated because of caching reasons? Did you take Optimize C++?
Oh, no.
Okay. Yeah. All right. Cache. It's all about cache.
Gotcha. Yeah, I'm just trying to like understand like why, like what's a scenario where
This is slow. This is slow. Talking to this is slow. So you thrash this as much as you can. So this gets updated. Then at a particular time, you say, now update the hardware. You don't just roll with it for right now. It'll make more sense.
Is that the update call?
Yeah, the update call. So, so what's happening here is we're going to create a sprite, right? So create a sprite. I give it a name. Then I just sit there and initialize this sprite. And so what the sprite is going to do is it's going to point to, a sprite will point to the hardware sprite. So here's the hardware sprite. So this is the Azul sprite. And so here's the hardware sprite. Let's keep it small there. And then it will also point to an image. The image has a picture of the rectangle and the texture. And then the texture will point to the hardware texture. So basically, sprite, we don't talk to directly. Texture, we don't talk to directly. We're having our buffer or adapter classes going this way. So here, this is the legacy or hardware class, right? So this is the hardware or legacy class. So it could be different data. And so what you do is you put another class in front of it, and it's going to condition the data there, and you can control when it crosses that line. So you use this to interface from one class to another, also to insulate the class, right? And that's an important aspect here. Our data is going to look the same, but we can change the format. We can say we can use fixed point, and we can use integer, we can use floats, and then we can condition it so when it goes over to the hardware class, it goes into the format it expects. We can use degrees, and we can condition it back to radians because that's what the hardware expects. But we also can insulate it. So no matter what, we get to have one location where we talk to that device, right? So that's the adapter class. It's really simple. It's just a wrapper class. And so what we're doing is we're taking the texture. So let's go from the texture out. So texture, I'm just gonna give it some enumerations. Alien, stitch, bird. And I have the texture class. So I just initialize the data. So it has the name and it's holding a pointer to the hardware text. So let's look at that. So. Right, so here's the texture class, and what it's going to have. There's texture class. It has the name. There's the choices of the names. Some names, and then it has a pointer that it owns. So it's going to be in composition. It points to the texture class. And this is the texture class for the hardware, right? So that's the first abstraction. So now if we look in the game code, we just sit there say, create a new texture. Its name is birds. and gives the string name. And now it goes into our wrapper. Our wrapper says, okay, this is pretty straightforward. It just adds our name, and then it's going to create a new hardware texture and hold a pointer to that. So basically, it's just creating this guy here, this one here, and we're going to always access it from this guy. So this is the guy we're going to access it. This is what it's going to talk to. So now the image. So let's take again the green bird. And so now our green bird, we're going to say the green bird, we have an image. So let's look at here. So we pull up resource. All right, so the green bird, we're talking about this little sub rectangle here. That's what we're talking about. So the texture is the birds, this image is a sub texture here. Right. So our image now is it's going to be called green bird, and the texture is going to be pointing to the bird texture, the pointer for the bird texture, and then here's the sub rectangle, right? So we can look at the image class as birds. It passes in the texture pointer and the sub rectangle and the name, right? So there it is. It's pretty straightforward. So now we're going to have here is an image. An image now points to a texture. Think there it is, points to a texture. But it also needs to have has data to the rectangle. So it goes, okay, well, fine, here's your rectangle. Okay. Now we have a subregion in this. So now let's create the sprite. So sprite has a sprite name. It says which image am I using, and then what is the screen rectangle. So now we look at the sprite. The sprite has the name, the subregion, the hardware sprite, and then it's XYZ scale and angle. So it's data. So now all right, so points to the hardware. So this is the hardware sprite. Let's put it down here. So that's hardware sprite. And it points to an image, boom. And it has its own X, Y scale, scale X, scale Y, and angle. Okay. So now when we want to update it, update's going to take these data and push it to the sprite. It's going to push it to this hardware sprite. So let's look at this here. So here's the update. Let's look at the green bird only. All right, so here we go. So we have we're going to change its X, so change its Y, change its angle, and we can kind of see so here's it's changing its position and it's changing its angle. Let's skip the angle. So let's see. Then when it hits the extreme, it's going to change directions. So now it's going to go too far down. This is going to vector back up, too far vector. So it's going to just ping pong around. Right. So all we're doing here is we're just changing X and Y, changing X, Y, changing X and Y on our update loop. And what we're going to do now is we need to push that to the hardware, because great, we changed this guy all day. We never we have to update this sprite. So this might be the better way to do this.
Just to clarify, when it gets pushed to the hardware, you mean that's when like the user sees the changes?
Right.
Right.
That's when the hardware sees the changes. So here we go. So this is it. So what we have here is our game is, changing these values. Right. And then when we sit there and say, okay, call update, it goes, okay, take these values, copy it over to the hardware. Now this thing has all these values. So let's say this is 5 and 15, right? So we can change this. Let's say the X right here. Let's say this is currently the value is X is 10 and 10, X and Y, right? We can start changing this. X is 3 and Y is 17. No. This other thing, we just collided with something. It's not 17 anymore, it's 20. So we can change this and change this and change this. Hardware doesn't know about it. It still thinks it's at 1010, right? When we call update, now this is going to get pushed over. So now this becomes 3 and this becomes 20. Then when we say render, it's going to go to here and it's going to call its render. Now that gets drawn.
Okay, and that's how the bird moves because it continuously calls the
Right,
update.
is when you call it the render. Yeah. So, but because a sprite needs an image, sprite needs, here it needs to know what texture it is. It needs to know what sub-region. We just point to an image. The image has the rectangle right there. Then it also points to a texture, which then points to that whole big box. So this is basically just a way to start abstracting this, because we don't want to have the spaghetti code where you have every function has to know about everybody else. That's the whole goal, right? So if this is your texture, right? This is your image, right? Here's your image, right? Here's your screen. Right? And then you might say to me, okay, I want my sprite here. So there's the X and Y, right? And then it points to an image, which goes, okay, that's all this image, right? And then it's like, okay, what's the size of the box? There it is. This is the box. Now it points to the texture, which then points to this guy, the big green thing. So from my perspective, all I worry about is moving the sprite around, and then it kind of goes to the pointer to the image, which then points to the texture, which points to the subregion. Once I set this up, I kind of like, I'm done with it. This is all I'm worried about is moving the object now. If we didn't do it that way, you would have to go through here and update this completely each and every time. You have to sit there and update the texture, update the sub rectangle, update the screen rectangle. You have to update all this stuff every single time. So what we're doing is we're abstracting it so we don't have to touch smaller amount of pieces. So now in the game here, we call update, and updates is going to do the push. It's going to say hardware, Azul sprite. Here it is, here it is, here it is. Now delegate it. Now hardware, you update it. So this is the wrapper. So what's happening there is this. the update function takes the angle XYZ, copies it over here. So angle, right? So it does the copy or push. And then it's going to do update the delegation. And then what that's going to do is go here and it's called its update. And then this is going to push it into hardware. So what this might help you guys better. Why do I have this hardware and all this layer? Because some people I think are still not understanding what I'm trying to say here. We have C#, we have the application, right? Right. And inside of this, we have a sprite. Here's our C# sprite. Right. This C# sprite is going to talk to the Azul sprite, which is also in C#, right? And this has the X, Y, SX, SY angle. And you're like, okay, so what? This kind of seems silly, right? This one has the X, Y, SX, SY angle, right? They both look the same, right? But then this is going to push into a C++ module. And this is going to basically create a sprite here. And then it has its variables. And this talks to the actual graphics card. So this cost right here, if you just change this sprite a lot, so if you just change, the Azul sprite a lot, you're communicating to a conversion from C# to C++, which talks to the hardware. That's slow, right? So this is slow. So what we do is we try to always talk to our adapter class. And so our whole game, let's go boom, 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 hits this a bazillion times. When it's all settled, we go, okay, we're done. Now we do the update. And then it gets copied over to this. And now from there, it kind of goes down its hardware route. Does that help a little bit? Okay. So this is where we're at. Actually, I have 5 more hours. All right. So the problem right now is when we look at this class, we need we have 4 objects moving around on the screen. So what we need to do now is we have this basically cut and paste 4 times, each of the objects cut and paste multiple times. And so you can see here in the game code, we have 4 sprites for tracking, 4 speeds we're tracking, 4 images we need, 4 sprites that are on the screen. Then we move the object each bird around with whatever code we want to do to move them around. Then we have to sit there and call for renders, right? Well, once you have, let's say you had 300 of these, you're not going to keep track of 300 variables. It starts to fall apart. So the trick is, what we want to do is start using managers. So let's start adding managers to this. So first, I'm just going to take the Space Invaders and just get rid of all the game code, the sprite code, and just load up a manager. So here I have the manager, and what I'm going to do is kind of load up our manager here. So we have manager base. I have an S node manager, a node manager. We have a couple things going on here, and just kind of prototype it out. Oops. So, we can have it as an S node or, or double link list manager. So single link or double link list manager. We have an active and reserve. We have the iterators. And this kind of just is just prototyping this out. So here I added just a gobs of code to get this up and going. And then I'm just going to shake this out really quickly here, add to end, add to end, kind of stuff like this on the code. And what this is just going to do here is basically add the managers, and I'm just shaking it out to make sure it kind of reasonably works, right? So now that we have managers stubbed in, now we're going to turn around and add the sprites and textures to it. So all right, so here we go. So here's the diagram. So yeah, the diagram yet. All right, so here's the image class, and then the sprite class and the texture class, right? I haven't connected them up yet. So I just added those into the system, and this partially cleans up the game. So now the game is using two textures. It's using the images for Angry Birds, the images for the Pac-Man. Then I create the sprites for the Angry Birds, create the sprites for the Pac-Man. Then I rotate and translate and update all those guys, then I draw them. So here I just stubbed in textures, sprites, and images. So when you start to develop, you don't try to do everything at once. You take it a step by step by step. So in this case here, I'm just showing you, okay, we have the textures, we have the images, we have the sprites. And so what we have now is this. So we're going to have a sprite. And this sprite points to an image. And then this image points to a texture. There we go. So there's what we have. Now, in reality, there's, kind of like this Azul sprite kind of sitting down here. There's the Azul texture sitting over here. But that's really, once we did the wrapper once, we don't even have to worry about it anymore. So we're not too stressed out about those two things, right? So this is what we have right now, but we don't have any management on this. We have the management stubbed out, so we started to get managers working here, but we haven't hooked them up yet. Right. So now let's go to managers. So now what we're going to do is add a manager. So we're going to put a manager of images, a manager of textures. So what I'm going to do here is here's texture. And then what I'm going to do is derive the texture from D-Link and the texture manager from manager base. So texture from D-Link, manager database. So you see the texture here is the same as the last drop, but now it says derive from D-Link. Right. And then I have the sets in here and then the wash, contracts. Then I have this the image manager. The image manager, oops, this is a texture. Yeah, this should be. All right, so the image manager now is basically going to image manager drive from man base, imager going to drive from D-Link. Okay. So now what we got now is when we create an image, we have add, and we're going to basically wrap that functionality into the add. So create the texture manager, create the image manager. So we create those, right? So when we want to create a new texture, what we did before get rid of some of these. What we did before is when we created this, we would say new image, and then we whole new image, and we keep the pointer, right? So we do a whole new image, we keep the pointer. We go create a texture and then keep the pointer. So that's how we used to do it. Now that we got the managers, why not combine this data here, this new, into the manager. So instead of doing create it and then add it to the manager, I'm going to take this new part here and place it inside the add function. And what does the add function need? It just needs the name and the string. So now in the add function, I just take the name and the string, right? Now I use my manager to go get me a new manager off the front of the list, set the data, you know, wash it, add it to the list. Right? So instead of me creating a new one directly, I can now create one directly from the manager directly, and it can deal with it. Same thing's true for the images. Instead of me creating an image, I can have the manager create the image and then add it to the manager. And then it can create the image, add it to the manager. So I can have the manager create it and manage it. So what we have is this. Instead of me creating an object and, here's our manager. Right, so so what I'm going to do is have here, I'm just going to take in for my add, I'm going to take in my parameters, X, like the name, rectangle, and then it's going to yank one of these off and then fill in the data with the name and the rectangle, and now it's managed. So basically the add function becomes a factory. So a factory pattern is really quite simple. It's just going to create objects and hand it to you. So here's a factory. And basically what it's going to do is you have an interface that describes how you want the parameters be passed to you. And then you're going to basically create one and hand it over, right? Let's see. There you go. So you're basically going to, someone's going to create the objects and hand you the object back over to the client. And now the client has a pointer to it, right? And so in this case here, this would be the texture manager. Texture manager will create textures and hand it to the client, right? So how does the texture manager do it? I'm just going to sit there and say, well, what we would do is we would take one off the reserve list and then use it, right? So we would have, the texture manager would have this. Right, we would take one off this list. take one off the list. Then we would add it onto the active list, right? Well, when we take it off the list initially, when we take it off the list, then we're going to fill it with new data. So set it with the data. Now that it's all set, now when we move it over, oops, when we move it over, it'll be moved over with the new data. So just by taking something from this list, something from the reserve and placing it onto the active, we're essentially creating a new one, Because remember, once we move over enough of these, right. Once we, we move one off the list and place it there, right? Move one off the list, place it there, move one off the list, place it there, right? Eventually this is empty. Then what we're gonna do, we're gonna refill it with new items. Well, what is the manager really doing now? It's creating nodes, right? So this is acting like a factory. So when I was saying at the beginning of the course, I said we're going to be dealing with class design patterns that are going to intersect multiple things. Well, now we have this. The manager is our manager here, right? Conceptually, here's our manager, which is really our texture manager, right? And then active. Reserve. Right. So this manager here, the roles it's playing is pooling pattern or object pooling. It's also using the template method, right? And now it's using a factory. Because when we say, give me another one, we're basically taking one from the reserve, adding it to the active. And if the reserve's empty, we're going to create another one, but we're always creating a new one. And then when we're done, we're going to remove it and it will go back on the reserve. So we're actually doing creational functionality here. And so this is a factory. So now this manager is object pulling. It's using the template going up and down the hierarchy and is using factory. So a factory is just some object that's going to create an object for you and hand it to you. Think of this as a car factory, right? So, this is a car factory. It's going to create a, so let's say a Ford Focus. And then you're going to get the Ford Focus to use, but the car factory made it, right? Or Volkswagen, here's a Jetta, and I hand it to you, and then you get to do this stuff. So all the factory does is create something on your behalf and hands it to you, right? So you think you can do this simply with just was just doing your new functions. And the problem is you need to have centralized construction of your objects, and you need to know how you're going to hook this up and what options you're going to give to it. So a factory isn't also a way to consolidate options. So there's not many different ways to do it. You can centralize kind of the way to construct something. So when you there's 100,000 options on a car, right? What tires, what rims, what tire valve caps do you put on it, right? There's 1,000 options on a car, but when you go in there, they say, do you want this car? Do you want, sport model or economy model? And just by choosing sport model, you get these options, or do economy model, you get those options. Then your other choices, like what color and maybe what kind of stereo. So they boil you down to 3 to 5 choices, even though those 3 to 5 choices determine 1,000 options. So a factory is a way to narrow down the choices to give standardization and to have some clean system create an object on your behalf. All right. So here, when we used to say create an image, in the past, we would say, create an image, new image. Now we're just going to delegate and say, you know what, manager, you create it. So we're just going to say, add an image to your system, or add a texture to your system. And that's how we're just going to use that. Right. So So now the next thing is we were able to create that. Now let's add sprite. So now to show you, remember I told you at any one time, all your objects are owned by somebody. And this is a critical concept. So we're going to have this. Here's your manager for your sprite. And then it's going to, all the objects are going to be here, and you're going to have multiple sprites. And what does the sprite do? The sprite points to an image. Right, manager. And then an image points to a texture. This is always the this is the active. Right. So a sprite will point to, but not own, an image. An image will point to, but not own, the texture. This sprite here might point to this one, and then this could point to the same texture. This one can point to the same image. Oops. I'm just going to draw them without the diamonds. They're all diamond, open diamond implied. So we can have this. So in a sprite, this can be a red bird, can point to the red bird image. So that's the same cookie cutter section, and it points to the same bird texture. And here it could be a green bird. It can point to a green image, which points to the same bird texture. This could be a Pac-Man, blue ghost, which can point to a blue image, which points to the Pac-Man texture. And what's important here is that every single class is owned by one. There's always one solid black diamond. So remember, we can have, here's some manager. Let's say this is image manager. We can have, it owns images, right? But we could have many different sprites all point to the same image, but all these sprites are in essence still owned by the manager. So at any time, there has to be one permanent connection to an object. You can have many objects point to you and even use you, but there's only one owner. And this is critical to keep track of the ownership. So how our system is going to work is that the managers own all the objects. And then we're going to be pointing between the objects to each other, but the managers own the objects. And the objects are going to either be on the active or the reserve. But either way, it's a solid diamond that's connected to it. Does everybody understand that?
Yeah.
All right, so now we'll go to the next one right here. I think I clicked it. Let's see. So now here's the sprite manager, and the sprite manager is going to add a sprite. So it says, okay, here's the sprite's name, red bird. It's going to use this image and this rectangle. So when we look at this right here, what we hate seeing in our code is new. New is the Achilles heel for performance. Because what's happening here is this image says create a rectangle. We go into add. The very first thing it does is it takes it over here, uses the data, and it's done. So that rectangle, this thing is created, it's alive, and then it goes into the add function, and then it's consumed. So here, it's set. The set just scrapes the data off of it. So here's this, and it's just going to scrape the data off of it and consume it. The problem right now is that this thing's getting thrashed. So this gets created and this gets created, right? The same thing's true with the sprites. The sprites have the rectangles being created. So what we want to do is, instead of having, you have to create a dynamic object and pass a dynamic object into it, you're going to pass some parameters so we can have those news be controlled by the manager. So, I want to do that in a second. First, before that, let's look at this. Who owns the texture manager? We just called new and we get a pointer back. Who owns the image manager? We just call new and we get a pointer back. Problem is, we need this image manager other places in our code. We need the sprite manager other places in our code. So one trick is to make it global, so then everybody gets access to it, right? That kind of feels dirty. So what if we made these things globally accessible anywhere? And so what we're going to do is convert these to singletons. So singleton is basically it's a global instance, and it has a controlled access to get there. And basically it's created at the time, the first time it's used. So what we're going to do is convert these classes here from calling new, and we have the new buried into the class itself. And the advantage is when we create an image, right? So create an image, we're gonna get a pointer to it. Then we have to turn around and first of all, check to make sure that pointer is valid. That's the first thing we have to check. Then later we have to take that pointer and pass it to, this is an image, to each sprite we need to use. So now we have to grab it, handle it, and pass it on to another item. Well, technically speaking, since this is a pointer, that pointer could be invalid. So this pointer to this image could be invalid. So we have to test it again here. So this becomes a problem. So why don't we move everything into a singleton? And a singleton gives you single point access. There's one and only one in the whole application. It's made in a lazy standpoint. It's made the first time you use it. It just ensures basically easy access. It adheres to the don't repeat principle. And it never gets deleted. It stays alive for the whole duration of the project. And then when the project shuts down is when that memory is actually released. Right. So let's go there. So here's a singleton image. And instead of calling new, so what we had before was we would call, here's the image, and we say call new, and we get a pointer back to it. We're going to change that line of code. What we're going to do here is say image create, image manager create. And so what we're going to have is the symmetry of functions here. So for static objects, static methods, we're going to have create and then destroy. We'll have add and remove and find. And these are all going to be the static methods right here. And every manager class will have create, destroy, add, remove, and find. And so now if we need something, we just will go, okay, image manager. The first time, we just go create. And this is where we can put the reserve 0,3, right? So we create it once. Then when we use it, we just do, image manager dot add or dot remove dot find. And then when we leave the game, we do image manager destroy. And this is when we give the memory back, and this is where we can print the stats. So how do you create an object statically? So when you create this, so here we're just going to say image manager create. So we create, and we can still have the same reserve the number, growing the number. They're a number that's defaulted. So we still can override this and put down, 3,6, so it can still be parameterized. But what we do here is we're going to sit there and say, is the instance null the first time through it? So we're going to go down all the way down here to the construction, and we're going to have a variable called instance. And so we have the instance, we initialize it to null. So the very first time it gets called, it goes, all right, you're null. Call the new there, right? That's it. It calls new. So this basically is the constructor, right? So this is the old code that we had from the last drop. So last drop here. Oops. Yeah, here's the last drop where we set there's a new, the object will get a pointer to it. Now in our new code, we wrap that inside of the create. So now it goes image manager dot create. We go into that. It goes, okay, then the instance is null, create a null. Now here's our pointer. From this point on, we never call new. If somebody calls create again 2 times in a row, this assert should yell at you and catch it. Right. So now the next problem is, cool, you got image manager. How do I call add? Well, in the past, what we did was we would sit there and say, we have that pointer and we go the pointer dot add, pointer dot add, but we can't do a pointer dot add anymore. We have to do it statically. So what we do here is we do pointer dot image manager static method add. And then the first thing we would do is say, give me the pointer. So we have a static method called private get instance. And what this private get instance is going to do is go inside. This is a private method. It says, return the pointer to instance. So it returns the pointer instance, but it's private, so it can't go external. Comes back up to the add. It's like, cool, thank you. Now I got a pointer. Now I know how to do the rest because I have a pointer. So we have this, we have pointer to the instance. It's equal to null. We sit there and say, okay, create. And then now this is not null. This points to a image manager. Right. This is does everybody know about static methods? I feel like I'm more or less just teaching static methods today.
I think I could have
Yeah.
a little clarification on it. Like, I don't think I 100% know it.
A static method is when you have a class. So let's say here's a class dog. When you want to access a method in here, right? So you want to say, foo, you need an instance. So you need to go dog, p dog equals new dog, right? And now you can go p dog dot foo. So this part right here, that's an instance data, right? But if you have a static method, we'll call it Jeff, right? So you have a static method called Jeff. You can't call pdog.jeff. You have to call the class. The class name is dog. So it goes dog.jeff. And first it's like, what's the big deal? The catch is on a static method, I can call this without having the object even created. So I can sit there and say, you know what? First line of code is dog.jeff, and that's okay because it's a static method. So static methods, you have one method, or this method is used for every single instance of the class, whether there is a class or not a class. It's statically bound. It's not
Yeah. So there's not constructed, and then if it has
Nothing.
default values,
There's
not
nothing.
even carry
You
that
can-
either.
You can do anything. It's just a so homework if you haven't done this, and I'm really pissed off at your class before you. Look up static methods and static variables in classes. In classes. Look those up and study that. So essentially right now, we have image manager, right? Definition. It doesn't exist. We have inside of this a static instance pointer. Okay. It's initially equal to null. Now, well, we can create a static method called create. And then basically the job of create is to p instance equals new image manager. So this is going to create it. Now, because it's static, I can call this anywhere, right? I just can say image manager dot create. So I'm going to say image manager dot create. Right? Because I don't need anything. I just call it directly because it's static. That's going to initialize my instance. Then later, when I sit there and call another method, static method dot add, I need to get the instance. So I have a private static method called get instance. And that's going to return the instance to the add, and now I can use it in my add. So let's just watch the flow of this. So here's my image create. So image manager dot create. I go to image manager, and I could talk to this because it's a static method. So I can grab it first. It's public. I can do it. So I grab it, and basically I go, oh, my instance variable is null, so create one. Done, it returns. Right. All it is created one. Now my add, so it's image manager. I need to call add function. My add function, I don't have a pointer anymore. There's no pointer. Nothing's been returned. I have no pointer. So I have to call a static method again. So I call a static method dot add. I still need that pointer. So how do I get the pointer? I call a static method internally to the class saying get private instance. And all it does is return the instance. So that returns the instance. And now I get a pointer back. Once I get a pointer back, now the code from this point down is the same as the code before. So the code before, when I would sit there and say pointer.add, the code before used this pointer, this pointer, this pointer. Well, I don't have this pointer because I don't have an instance of it. So I have to go get a private instance. Now I use that private instance name here. And now I can start doing the rest of the code. Okay, so once you did that, then you convert everybody over to singletons. So now our texture is a singleton, our image is a singleton, our sprite is a singleton. Then you rework everything to do that accordingly. So sprite manager add, the first thing it would do is get the private instance. And I think I'm going to stop here. All right. So questions.
So where are class static variables allocated?
They're actually, wow, I thought they would. So here is, say you have a class dog, right? Class dog. You have two different types of variables. You have instance variables. And static variables. So let's say static variable is a, and instance variable is x. Okay, let's pretend that. So when you go dog p dog 0 new dog p dog 1 p dog 2. Okay, so we have 3 dogs. What we really have is this. Let's say our value is 5, 6, and 7. 5, 6, and 7 is x, right? So this one points to there, this one points to this one, this points to this one, right? But let's say our a is 50 is 88. Over in the BSS, there's a space reserved for dog, and inside of there is a 88. So this class, each of these classes point to that one.
VSS.
Yes.
What's that?
Data segment, right?
Yes.
Just don't know what it stands for. That's all.
So what we have is one copy of the data. And then here we have 3 instances of the data. So your data is driven by instance. Every time we call new, it's only, you only get the instance data repeated. With the static data, there's only one and only one copy ever. There can't be 2 copies or 3 copies. There's only one copy of the static data. So everybody shares this. So, so this is how the data is broken into instance data and static data. And you got the same thing here is if you sit there and have public, you know, private, protected, you can have, you know, methods, right?
So that's different from the stack and the heap then, right? Or is it like
No,
what's the
this is
talking about the BSS? I'm sorry, talking about BSS.
BSS. It's just it's stored in a different location. It's outside the dynamic. It's in the read-only segment, or not read-only segments. It's in part of the heap.
Oh, okay, okay. I was just wondering.
So you have, you know, public, private, or protected. You have instant methods, right? And you have also static. Static methods. And again, they can be public, private, protected. And these methods here, whatever methods you have here, void foo2 static. This line of code here, anybody can access it. It's anybody just goes dog.foo2. If you are doing foo here, you need to have a pointer. So you have to be p dog 0 dot foo. If I wanted the static one, I just can go dog, because that's the class name, dot foo2. So instance methods, you need an instance, a pointer. Static methods, you don't need a pointer because it's tied in. There's only you can only, no matter how many instances there's, no matter however the data is, there's only one way to call it.
So does that make like a static, anything static? So you said it's on the heap. Is that any way related to new? Like I'm just not, like how is that? Is that
Don't worry about
related?
how it's made.
Oh, okay. Okay. I can do that on my own.
It's presto changeo. It lives in a different space.
Yeah.
Yeah, just because you use the keyword static, if the program compiles, it found space for it. If it
Oh, so
doesn't-
it's actually done before it even runs. Okay.
it's done at compile time.
Oh, okay. 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 That
Now,
answers my question.
it just reserves a space at compile time. It reserves a space for A at compile time. It doesn't guarantee what the data is. You can change that.
Okay.
You
Yeah.
can write that data. So you can change the data on your static variables.
Yeah, I gotcha.
So, you know, typically you have read-only section. Then go really technical. Here's the heap. And then out of the heap, a lot of people don't know this. This is the stack. Is actually in a heap, but you didn't know that. And then I should have put the stack in a slightly different location, but then here are the static variables that you can read and write to, right? So these are read, write, right? But if there's static variables that you can't change, they live here. These are the constants. Right. And then also inside of this is your actual code. And then the rest of this is free for all. So it's kind of the layout of an executable.
Thanks.
So when we talk about dog and it has a static a variable, it's going to live over here. The variable a will live right there. Right. If you declare in C# in Java, you can't declare an object on the stack. You have to only declare it on the heap. So when you go p dog star equals new dog, this guy lives over here. And so let's say that's its int x. So then x lives on the heap. You can't put a class object onto the stack. You have to put it on the heap. In C# and Java. Oops. Other questions? All right, so this tells me a lot. So what I'm going to do now is PA2 and Sprint2. Somebody's mic's active.
Sebastian, I think, who has his mic active.
Okay, there we go. Or did just fixed it. Thank you. All right, so where we go here? Okay, so sprint 2, PA 2, right? All right. So here I'm going to do iterators. Right? I'm gonna do an iterator, I'll do singletons. And a factory. So your design pattern practice is those things. Right. And then sprint 2, what I'm gonna have you do is have sprites, images, and textures, all with singleton managers. So that will be sprint 2. And so you get a lot of influence from the material I give you today, but you should have all the skill sets to do this from your PA2. Does that make sense?
Yeah.
So, you know, again, the pattern is the PA is where you're going to explore and understand the pattern. And then the sprint is where you're going to apply the pattern in the game environment. So sprint 2 will always be, sprint 1 was a copy of the game over and record the movie and, you know, make sure audio is okay. Sprint 2 is copy that over, call it sprint 2. Then I'm going to give you instructions on what to have in your demo. And then PA2 is going to go through these 3 patterns. It's just be more unit test, no game environment, just raw code. But it'll have a unit test that will tell you if you're successful or not. And so that whole idea is that you get just cleaner and better of the patterns without the cumbersome of the larger game environment. Okay. All right, I'm going to stop it now and do a quick bio break, and then we'll do office hours. Okay.
Thank you.
All right.
Thank
Thanks,
you.
everybody.
Thanks.
Thank you very
Have
much.
a great evening,
Have a
everyone.
good one.